Today we're going to look at function notation. So first, here's all the standards that we will be covering today and in the days to come. So this is just a list of standards if you want to go through those. The next thing is your success criteria that we often look at. So you're going to evaluate functions using function notation, interpret statements that use function notation, be able to graph functions represented using function notation, and evaluate functions of two variables. All right, so often you will see function notation written like this. F of x is just another way to write y. When you see it in f of x, that means they're using function notation. So f is the name of the function. This tells you that x is the input value, so you're inputting x into some function. And this tells you what the function does. This function multiplies the input value by 2. So this is just an example of how function notation is written. All right, some vocabulary that you need to be aware of. Make sure you put this in your notes. Function notation, instead of y equals mx plus b, you will see f of x equals mx plus b, or some other variable here, but still in this form. So the notation f of x is another name for y. If f is a function and x is in its domain, then f of x represents the output of f corresponding to the input x. You can use letters other than f to name a function such as g or h. A function of two variables is a function where the inputs are ordered pairs. Each input, x and y, is paired with exactly one output. A function of two variables can be written using function notation, such as f of xy, or a newly defined symbol, such as the star. In both cases, x and y are independent variables. Okay, so this is a special way to look at functions. If you look at it with more than one variable, you can see that both of these are considered independent variables here. All right. Let's look at some examples. All right, so evaluating a function. So example 1, evaluate f of x equals negative 4x plus 7 when x is 2 and x is negative 2. So it's giving you two different input values, and it wants you to evaluate this function. So we're going to put the name of the function. So the first one says f of 2, because it says let x be 2, equals negative 4x plus 7. All right, so we're going to take the 2 and we're going to substitute that in for x. And then we're going to evaluate. So f of 2, negative 4 times 2 is negative 8. Negative 8 plus 7 is negative 1. So your x would be 2, f of x would be negative 1, or your y value would be negative 1. So x is your dependent, y would be your x is your independent, y depends on what value of x you plugged in. All right, so f of negative 2 equals negative 4x plus 7. So f of negative 2, again, this is the name of your function. And it tells you to input negative 2 in for x and then solve. So f of negative 2 equals negative 4 times negative 2 is 8. And then 8 plus 7 is 15. So f of negative 2 is 15. F of 2 is negative 1. So again, you have an input and an output. This is your input, independent variable. This is your output, dependent, depends on what value of x you plugged in. This is my input, and this is my output. So if I wanted to look at these as ordered pairs, okay, as ordered pairs, this would be 2, negative 1. And this one, the second one would be negative 2, 15. And if you plug those in and check them, you would see that these two ordered pairs would be solutions to that equation. All right, for example 2, we are simply explaining the meaning. So it says, let F of T be the outside temperature in degrees Fahrenheit T hours after 6 a.m. Explain the meaning of each statement. So explain. So again, we're explaining what F of 0 equals 58 means. Now, reading. When you're reading function notation and you have a 0 here, that indicates the initial value. So the initial value of f is the value of the function when x is 0. So in this case, when x is 0 or t is 0, this says that the initial value is 58 degrees. So since we know it's anything, all of these are being determined after 6 a.m. So this tells us at 6 a.m., the temperature is 58 degrees because the initial value is like when it starts. It started at 6 a.m. All right, so f of 6 equals n. So explain the meaning of this. 6 hours after 6 a.m. would be 12 noon. Okay, so 6 plus 6 is 12. So at noon, all right, the temperature will be in degrees Fahrenheit. So it just gives us a variable here. That's okay. It just says explain the meaning. So f of 6 equals n. At 12 noon, it is in degrees Fahrenheit. All right, C part. What does f of 3.5 less than f of 9 mean in this scenario? So again, it says let f of t be the outside temperature in degrees Fahrenheit t hours after 6 a.m. So 3.5 hours after 6 a.m. would be 6, 7, 8, 9, 30. So at 9:30 a.m., the temperature is less than at 9 hours after 6 a.m. So let's see, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3. So this would be 3 p.m. Okay, so this says, if you're saying how to explain this, at 9:30 a.m. the temperature in Fahrenheit is less than the temperature in Fahrenheit at 3 p.m. All right, so the most important thing here is to read the question and understand what the given information is, okay? So we're talking in degrees Fahrenheit. T is in time. Time is the number of hours after 6 a.m. So each one of these we had to determine based on that information. Being able to explain things will help you understand math tremendously. All right, example 3, using function notation to solve and graph. All right, solving for the independent variable. All right, think back, definitions. Our independent variable is our x value. So if we're solving for x, that means we must be given h of x. So this says for h of x equals 2/3 x minus 5. Find the value of x for which h of x equals -7. So you're going to take the -7 and plug it in for h of x. And then you're going to solve for x. So remember, to solve an equation for a variable, you have to get it by itself. And we have to use properties of equality. So we're going to use our inverse operations to do that. So we have -5. So if we add 5 to both sides, that goes away. -7 plus 5 is -2 equals 2/3 x. All right, to get rid of a fraction, you can multiply that by the reciprocal. So I'm going to multiply both sides by 3/2. 2 times 3 is 6. 3 times 2 is 6. That equals 1. That's what we're trying to do. Eliminate the fraction. So 1 is assumed to be there if we just put an x. So we're going to have 3/2 times -2. Remember, multiplying fractions, you can reduce. Since there is a 2 here and a 2 here, we can make that a 1. And that's just going to be 3 times -1, which is -3 over 1, which is just -3. So x equals -3 when h of x equals -7. And again, that would be our ordered pair. -3, -7 is an ordered pair that if we plug that into this equation, this function, it should make a true statement. The left side should equal the right side. All right, example 4 says graph f of x equals 2x plus 5. All right, so it says study tip. The graph of y equals f of x consists of points x and f of x. Okay, so like instead of x and y, you've got x and f of x. Again, it's just function notation. It's the same thing as x and y basically. All right, so in order to graph a linear function, first you're going to have to pick values of x. Remember, x is our independent variable, so we can choose any x's we want. All right, so to be consistent, we normally consider a couple negatives, 0, and a couple positives. And this gives us a good idea of what the graph's going to look like. All right, so just plug these in one at a time. -2 times 2 is -4. -4 plus 5 is 1. Okay, if you need to write these down to do this, by all means, please do so. All right, -1 times 2 is -2. -2 plus 5 is 3. All right, 0. 0 times anything is 0. 0 plus 5 is 5. And then plug in 1. 1 times 2 is 2. 2 plus 5 is 7. And then 2 times 2 is 4. 4 plus 5 is 9. So very quickly you can generate a table. And once you have ordered pairs, then you simply put the ordered pairs on the graph. So remember, your x is your horizontal, your y is your vertical, and y today is the same as f of x, or every day actually. This is in function notation, so we have we have x and f of x. All right, so if we go -1, 3, go -1 to the left 1, up 1, 2, 3. Let's put a point there. And then, I don't know why I did that. I read that completely wrong. I skipped the first point. Well, I can leave it there. Let's go ahead and go to the first point. -2 up 1. So -2 up 1. And then I already graphed this point first. I don't know if I skipped the first point, but I went -1 up 1, 2, 3. That point is there. 0, 5, 0, 1, 2, 3, 4, 5. And then 1, 7. We know this is 5, 6, 7. And then 2, 1, 2. This is 7, 8, 9. All right, so once you have those points graphed, then you can create a line and put an arrow on both sides because this is a continuous function. Any x I plug in is going to give me an output value. So let me put a line on here. Okay, so it's not perfect, but you can see I've got this line on here and it should go, it should be a straight line through all of those points if I had graphed them in the exact spot that they would be in. So you would have a linear function here that you graphed based on this equation after you generated this table of ordered pairs to do that.